First of all, thank you very much for inviting me to Hanover. It's my first time in this city. I've been to Germany quite a number of times, and I think maybe that needs to go down. There, are we not getting feedback anymore? Can you still hear me? Yes. Okay. Now, I know some of you folks actually don't know me. I run into some of you. So my name is Curtis Poe, better known to much of the Perl programming community as Ovid. I wrote the test harness which ships with Perl. I have commit rights to much of the testing Perl chain. I've been doing this for a long time. That's kind of my background. And I'm here as part of my company, allaroundtheworld.fr. So if you ever need consulting or training on any of this, or international IT recruiting, talk to me. So that's enough of the pitch. I'm here to talk about testing lies, and the very first one is actually the title. These are testing half-truths, but calling it testing half-truths isn't really as fun as a title. Before I go into this, though, I want to talk about bits of evidence. It's an excellent presentation. It's available on SlideShare. This is also available on SlideShare. Just go to SlideShare/Ovid, and you'll find my slides. Bits of evidence. I'm going to just give you a quick summary of what he did. Dr. Greg Wilson, he talks about evidence. Evidence is extremely important, and pardon the tautology, but he finds evidence that evidence works. And when we're talking about science, we need evidence. We don't want to just randomly state that something is true. We want to actually have something that is testable, that we can back up. But as programmers, we tend to rely on word of mouth, our personal experience, anecdotes, and the whole saying that, oh, but my truth is different from your truth. No, sorry. As soon as someone says that, you know something is wrong. But we use these evidence, we defend them vigorously, so I want to just kind of change your thinking about testing a little bit. But first, evidence, it's important to think about what evidence actually means. Absence of evidence is not evidence, but evidence of absence is. And what I mean by that is there is no evidence that a god or gods exist. But because of the way they're typically defined, there's no evidence that they don't exist. So this is kind of outside the realm of this sort of thinking. That's kind of a faith-based thing. And I would like for software testing to not be that. So to really tick off a few people, we have a belief that small subs, that they're more maintainable, that they are more correct. But the reality, the evidence suggests that this is not true. And this is hard for me to accept. I assume that small methods or subroutines are better. So Steve McConnell, in Code Complete 2nd edition, he curated a lot of studies and put them together in a section about the length of a subroutine. And what many of these studies found is, so just walking through them, inverse correlation, the first study, they found that larger methods and subroutines, I'll just call them subs, larger subs were easier to maintain. Another study found that there was no correlation. Another study found there was no correlation, but larger subroutines were actually cheaper to maintain, and saving money is pretty important. Another one found that small routines tended to have more errors, which is surprising for us. Yet another study found larger routines required less maintenance effort. Again, this is counterintuitive to what we're thinking about. This also equates to cheaper. And then this other one, this last one by Jones, you had to approach a subroutine size of around 500 lines before things started to break down. This is challenging for us, but the reality is that reality is more important than your opinion about something. And this is probably one of the most challenging results I've discovered because it flies in the face of everything I believed. Of course, small subroutines are better. In case you're wondering, this is a 1500s book showing the Ptolemaic view of the universe with the Earth being at the center. Of course, that's wrong. So yeah, that's enough of the preamble. Let's get started. A lot of this stuff is going to be thought-provoking, but it's going to be obvious when you consider it. Some of it's going to possibly be offensive to you. Double-check everything. Question me. Don't just assume that what I'm saying is true. For example, this may or may not be Getty. So the very first lie, code coverage tells me what to test. No, code coverage does not tell you what to test. For example, this is the example I usually give to everyone right off the bat. So here's a simple reciprocal subroutine. Does anyone see a problem with this subroutine? I see lots of problems with that subroutine. In a static language with a reasonable type system, I'm actually going to feel comfortable if I've got a decent signature on that. But this test is going to give you 100% code coverage right there. The reciprocal of 2 is 0.5. Now, right off the bat, some of you are thinking floating point numbers. Maybe there's an issue there. But I'm going to go beyond that. What if we pass 0? OK, it'll throw an exception. Maybe we care, maybe we don't. What if we pass a string? Well, in Perl, the string 2 apples, we'll still pass that test. Do we want that? You know, what if we don't pass an argument, if we pass a file handle? What if we do pass a valid number, like a temperature? The reciprocal of a temperature doesn't make any sense. There's no reason you would do that. So just because it's a number doesn't mean that it's something valid to pass to that subroutine. There's so many exceptions you can come up with as to why 100% code coverage doesn't really cover what you're looking for. And the reason for that is we as programmers, I write software to create things. Testing should be an act of aggression. You want to destroy things. You want to not prove that your code does what it's expected to do. You also want to prove that it doesn't do what you don't want it to do. This is why QA departments are so annoying, because they keep kicking back bugs like February 29th, 1981 is accepted as a date, when we didn't think about that. They found out that you can't offer a birthday discount to a customer born on February 29th, and we didn't think about that. Code coverage is never going to tell you that sort of stuff. So we tend to get a sense of false confidence when we see our code coverage being too high. So imagine a subroutine that's never called. And in our tests, never called foo bar, great. We've got code coverage of dead code that we should delete. But because we have code coverage, it kind of looks like it's exercised, so maybe we shouldn't delete it. That's a little bit frustrating. So here we're talking about the difference between unit and integration tests, and I wanted to go over this in much more depth because this is a big frustration of mine. But unit-tested subs don't talk to other subs. But that's all your code does. It's subs talking to other subs. So if you're only focusing on unit tests, you're not really focusing on what your code does. Dead code is cognitive overhead. It's stuff that you look at and you've got to think about. And sometimes even with integration tests, you might have large sections of several classes all talking to one another that don't actually get called anywhere. And in fact, so even integration tests aren't necessarily what you want here. So dead code, by definition, can't be called via whatever your interface is. Whether it's a REST API, a web page, a command line client, whatever. So how do you solve this? One way I recommend to clients is in your T directory, I like to break things down by the different type tests. So I'll have a subdirectory called API. Run your code coverage against API. Nothing goes in your API subdirectory unless it's an API test. When you run code coverage against that, first of all, your code coverage numbers drop dramatically, which kind of makes me feel bad. But then you look at the code and you ask yourself, this code was not called via the API test. Is that because my API tests are simply failing to cover a case that I might want to know about? Or is it because it's a candidate for code that can be deleted because it's dead? If you don't like all those separate subdirectories and you like XUnit testing, I recommend test class Moose. You can tag tests with API or REST or whatever. And then you can create a special test driver just for those. That way you don't have to spread your tests out into a whole bunch of directories. You can put them all in the same set of subdirectories and then say, only run my develop cover tests over the tests that I want code coverage on. And so here you include test methods which are tagged API. It's another way of using code coverage effectively. There's a lot more I could say about that, but I'll just move on to code which is covered but not tested. So here we've got tests for forum. So we get our test website, we log in, we get our forum link, we follow a link called off topic, and then we test post OK, blah, blah, blah. Develop cover at this point is going to tell you all this code is covered. And that's a huge amount of code we're actually covering. Getting our test website, logging in, authentication, making sure we can actually get to the forums. We didn't test that. We exercised that code, but we did not test that. And in fact, the post OK, that pretty much says we didn't get a 500. It doesn't mean the post actually made it there, but your code coverage might lead you to a false confidence about this. You can sprinkle your code with annotations all over the place saying this code is uncoverable, so develop cover doesn't do that, but that makes your code a little bit messy. There's no clear recommendation on this one. It's something you simply need to be aware of. Just because you're calling the code in your test suite doesn't mean you are testing it. Does that make sense so far? OK, cool. So a quick recap on develop cover. 100% code coverage, it doesn't handle data. it doesn't really handle that we're testing that our code doesn't do what we don't want it to do. It just says this code was run through develop cover. That's not enough information for you. You don't want to be covering dead code when you're running your code coverage, because this can really cause a lot of issues where you have code which doesn't do what you want it to do. Even if your code is well tested and it's not dead code, if it's not called via the API, it doesn't mean that it's going to respond appropriately because you don't necessarily know what's being passed to it. So run your code coverage at the highest level as possible. Remember, covered but not tested code, that's going to be a little bit frustrating. That's not an easy thing to deal with. The summary of this is do not blindly trust your tools. Think about what they mean. Next slide, quality. Perl community is most test infected. I've written blog posts about this. I was lying. Maybe I was mistaken. I don't know. I won't say I'm fundamentally dishonest. But we consider ourselves so test infected because of how many darn tests we write. And we're good at it. So CPAN testers. This was from March 6th. 40 million test results over 30,000 distributions. And all these different platforms and all these different versions of Perl. That looks pretty darn impressive. Many modules only have a load test. Does it compile? Oh, great. Ship it. So garbage in, garbage out. And CPAN testers, they're aware of this problem. You need to look at the code you're borrowing from the CPAN, and if you're not sure about its quality, I'm not going to worry about DBX class too much. I like the module. I use it quite a bit. If it's an unusual module, there's one dealing with, that Peter Rabison just showed me about dealing with currency formats and PostgreSQL. I need to look at that a little bit more to find out if it really does what I want it to do. So once again, do not blindly trust your tools. So just because this information is available, you need to think about what it means. Backed up a couple of slides just to get a refresher to where we were. I was talking about the fact that Perl, much of our tests, we tend to focus on quantity instead of quality. And we steal a lot from other languages, the best parts, but we're not doing enough for testing. And I was talking about, in this case, specifically, all pairs testing is one of the many techniques that are available elsewhere. Had the 10 arguments, obviously. I talked about the coupling effect. Most things, programmers generally write nearly correct code, and most faults can be changed with a single line of code. But testing really complex things like that is difficult. 10 arguments can be 10 billion combinations, and obviously even auto-generated, that's going to be difficult to do. It's going to take a long time to run. But if we start combining pairs, and I'll explain that in a moment, we only have 54 combinations. And then you consider the different data types involved in each of the combinations, and I'll give you an example of what I mean. So this is just a simple thing I wrote to show the first set of pairs you would pass to the function you'd worry about. You just assign base values to all of your arguments, and then you start twiddling various pairs. So you start messing with arg1, arg2, and then arg1, arg3, arg1, arg4, etc., all the way down to arg1, arg0. So that's the first set of pairs. The next set of pairs, you've got arg2, arg3. You don't do arg2, arg1 because we've already covered that here. And then you go down again, you go down again. Does that make sense so far?
The orange one is a laser pointer.
Oh, cheers. Oh, wait. I have a laser pointer. I'm stupid. Thank you. So for this first pair, arg1, arg2, you think about interesting values that go in there. If arg1 is supposed to be a Boolean, the interesting values are obviously 0 and 1, true or false, whatever. If arg2 is an enum, say red, green, and blue, then you've got 6 different combinations there. Or if arg2 could be a float, what are interesting values for that? 0 is an interesting value. 1's an interesting value. -1. What about something which is really large, which might cause an overflow? That could be a really interesting value. So you get sets of interesting values for each of these. And then for each pair, you iterate through the sets of interesting values. And what it tends to do, you get a fast generation of your test cases this way, much easier than 10 billion pairs. And you're going to catch a lot of those simple faults. Simple faults that couldn't be exercised any other way. In many languages, you will find tools which will automatically generate all pairs tests for you. And sometimes you have to tweak them to say what your interesting values are. That's hard to do with Perl because many of these tools rely on static analysis to figure out what arguments are going to be. This is not easy for Perl, obviously. There are tools out there. You can Google for all pairs test case generation tool. And there's one for Perl which requires some fiddling. You can't do it automatically. I would love to see it be done automatically. But this is a way we can improve the quality of our tests and not just the quantity. So this is something we need to steal from other communities, tools they're using to improve the quality of their tests. Another lie, tests are documentation. No. I've written a lot of tests. So here's something, this is an extreme example, but this is from tcurry.t from regex common. Voodoo line noise. That's very confidence-inspiring, isn't it? My num equals renum real. Well, I know what a real number is. And then I try num base 10 separator, and then pass 0, 1, 12, fail. I don't know what these tests do. I don't have the foggiest notion of what these tests do. These tests are not documentation. These tests verify the code works, but they tell me nothing. They also don't have test descriptions, so I don't know what that means. So here's some output from Test Harness. I wrote Test Harness, and my tests are not documentation here. They're rubbish. Simple lives, death never happened, error okay. I don't know what that means. HTML token parser simple. I also wrote that. Here, the tests are a little bit better. So we say our tag start can is tag, and it should identify a token as a given tag, and it shouldn't give false positive. That's kind of better, but I was still kind of new at writing tests. And here, I was describing what my code did, and not the business rules, if you'll consider it that way, that I was trying to test. If you want tests as documentation, you need to keep a few things in mind. Tests are often obfuscated. Don't do that. Tests shouldn't be written as an afterthought. They should be written as carefully as your regular application code. So take a little bit more time in your regular code to write things so that they can be read and maintained. Do that for your tests, too. Missing test names, that's very frustrating. I often see, even if you have a test name, it says something like function OK, function works, and that doesn't tell me anything. And the tests often describe code logic, and they don't describe business logic. When I go into a client, one of the first things I say is, just give me a rundown on your business. I need to understand what your business does, what goals you're trying to solve with this code vis-a-vis your business, because that will tell me so much more than the average test suite does about what I'm actually looking for. So to make test documentation, there are some things you can do to actually improve this situation. As I said, you write them to be read, and then you want to describe the use cases. Not what the code's supposed to do, but the business proposition that it's supposed to solve. So if you use test fixtures, use test fixture names which describe very specifically what you're trying to test or accomplish. If you use subtests, then give subtests very descriptive names. And if you use test methods with an XUnit style framework like test class or something, give the test methods descriptive names which explain the use case. For example, here's a subtest. Does everyone know what subtests are by now? Okay, so subtest. Customers who are overdrawn cannot purchase products. That's awesome. You can tell exactly what this test is supposed to verify. That's documentation. I'm loading some fixtures here. Fixtures load customer overdrawn and chainsaw, because we all like chainsaws. Customer overdrawn, that's very clear what this is. By the way, also notice this variable name, overdrawn customer. So down here at our test output, our tap, overdrawn dummy, we do not like deadbeats. Those test names are not very descriptive, but at the very least we have OK1, customers who are overdrawn cannot purchase products. Now, this is documentation. By the way, about the well-named variables, it's very helpful if you can read what the code is supposed to do and get a sense of it from a single line. So customer would be a rubbish name for that variable in that test. Overdrawn customer would be an excellent name for that customer in that test. Take good care of how you write your code for tests. And if you use test methods, you can do the exact same thing. Sub, test overdrawn customers cannot purchase products. Exact same thing. Again, we have a description of the business case that we have here, and not just what the code's doing. There's also a BDD is extremely popular right now. We have some modules on the CPAN. Tutor Constantine wrote a Perl behavior-driven development that's available on SlideShare. I have not used BDD before. It's becoming increasingly popular, so I can't say anything about its efficacy. Some BDD, yes?
I haven't heard of it yet. Can you explain BDD?
BDD is behavior-driven development, where your tests are written in such a way that you describe from the business side, you know, given this, when that, I expect this. Okay. So, yeah, thank you for asking that question. I apologize. So, tests can be documentation, but it does take a little bit more care on the part of the developer to make sure that they really meet that case. And finally, TDD is a far superior testing methodology. Prove it. So this was a Microsoft study that I read, and it was fascinating, evaluating the efficacy of test-driven development industrial case studies. So they compared TDD to non-TDD, and they found that test-driven development increased development time by about 15%, but it had far fewer defects than non-test-driven development code. Now, does everyone know what TDD is, more or less? Okay. So that last line, TDD had far fewer defects than non-TDD. Can anyone see a problem with that? Yeah, I told you already. Shut up. Everyone, Sawyer is not allowed to ask questions.
Well, you told me too, but I can't see that there are no numbers in it, or no way to measure the output there. There's no.
Okay. Yes, I did give a summary of this. There's obviously a lot more in the study, but there was a glaring issue in the study.
If it takes 15% more time, I expect 15% effectiveness of the TDD.
Yes, but that's not the issue I'm covering here. So those expectations, I'll get to that in a moment. What is non-TDD? My goodness, is it no testing? Is it test last, test as you go? Is it, you know, your QA department beats up your code and then sends you to tears? They didn't say. I've read a lot of studies. Don't just read the abstract, by the way. The abstracts for studies often lie. Believe me on this one. Some of these studies say, we have found that test-driven development has increased quality by 2.3%, and then buried in footnotes in the study it says, but this is not statistically significant. So this is a beautiful quote I found in the study. Ignore their typo. A year-long empirical study performed at IPM using professional programmers found that their TDD practice helps programmers produce higher quality code. They didn't answer these questions. Higher quality than what? And what does quality mean? How do you assess this? Some of these studies would judge quality by how well it's architected. Some of them judge it simply by the correctness of the code. Does it do what we want it to do? So they're all over the place. And then I found, well, before I go to that, I'm going to talk about some of the problems with pro-TDD studies. They compare against straw men. They often don't describe what non-TDD is. This is rife in these studies. For some reason, professional programmers cannot write a proper study. It's very frustrating. They tend not to use blind studies. They're often using students, or they'll use programmers who use TDD for the first time, which is interesting because you might think they're less effective, or they might be more motivated to make it work. This can throw it off. It's hard to study this. So Kane Marr is a huge Scrum fan. He loves TDD, and he's preached TDD for years. And then one day he asked an interesting question. Does it work? So this is a very three-part series that he has online. You can Google for this title. The benefits of TDD are neither clear nor are they apparent. And in this three-part study, or this three-part series, he broke down all the various studies, and he read them extremely carefully. And study after study after study turned out to be an absolute joke. And so this quote that I very casually cherry-picked out of there, claims about TDD such as better design, better API, simpler design, lower complexity, increased productivity, more maintainable code, etc., are simply not supported. We don't see this in the studies. So when people are telling me, you have to use TDD, prove it. By the way, at the end of that, in part 3, he then goes on to say, but you want to use TDD anyway, because if you write more tests, you know your code's going to have fewer defects. He fell prey to one of the...
The people who had Burner, please go to Burner. The people, die Leute, die ihm geholfen haben, den Kranken dahin zu legen, bitte geht zu Burner. Sören.
English or German, I still have no idea what he just said.
This applies to the Germans too.
Okay. So basically at the end, when he was concluding, you want to use TDD anyway, even though it's absolutely not proven, because more tests means higher quality, he fell prey to one of the fallacies that he was picking apart in all of these studies. But despite that, he did a great job of breaking them down, and he actually links to a Google spreadsheet you can take a look at where he summarizes a lot of the studies and their findings. Their findings do not support the claims that TDD proponents make. But this is absence of evidence. It's not evidence of absence. Maybe these things are true. We don't know. So when I'm teaching a testing class, I tell my students, if you like TDD, great. If you don't like TDD, great. Don't stress about it. I'm not going to be religious about which testing methodology you have to use, because dogma is bad. So the summary of everything we're talking about here is, we know that evidence trumps anecdotes. But the reality is we don't always have evidence, because these things are hard to study. It is hard to stand over a programmer's shoulders and watch them do something and draw meaningful results out of this, because simply observing someone tends to affect their behavior. We need to pay attention to what our tools are doing. We need to think about what they're doing, not just what the numbers are that they're spitting back to us. Code coverage, very, very misleading if you don't think about it. If you do think about it, it's absolutely fantastic. I like taking a test suite and tagging various parts, so I can say, give me the code coverage of my database tests. Give me the code coverage of my API tests. Give me the code coverage of the web interface. That gives you a lot of very useful information. Code coverage of unit tests, that's just useless. So we also need to escape our bubble. Look at what other people in other realms are doing in testing, because that'll get you a lot of interesting ideas about the things you can do. And be skeptical about all of this. If someone's giving you if you're hearing a lot of hype about something, don't buy into it immediately. Ask questions, find out if they have evidence, and be skeptical of me. I could be full of it. Trust me, trust no one. There's another summary for the TDD fanatics. Don't sweat anecdotes for casual ideas, and don't accept anecdotes from dogmatists. If you don't know if an idea is good, we don't have a lot of evidence, don't worry about anecdotes. Okay, give it a try. But as soon as someone starts getting dogmatic and starts using words like always, none, or never, that's a big red flag. Be careful about that. So at this point, we have two choices. One, we can take questions, or two, we can go to my bonus slides.
Bonus slides.
Okay. Bonus slides. Hey, very handy. That's all. I'm kidding. So I just have one section that I'm covering here. I didn't know if I'd have enough time in the talk. Something called basis path testing. This is something we can probably do in Perl. We can do it now. There are some issues with it. But basically, basis path testing, we've got this long, very complicated section of code here. And all of us know that path coverage is very, very hard to do, to the point where it's impossible for a large-scale system. But let's say we're just talking about a single subroutine here with all these if-else statements. This is actually relatively simple compared to some of the other things that you might have. There is something called cyclomatic complexity. I'm not going to go into this terribly much, but it's something you can search for online to find out about using your favorite search engine, also known as DuckDuckGo. And basically, you count the nodes. These are kind of the places where you have decision points in your program, an if, an else, for loop, or Boolean conditionals, etc. You count the nodes. You can calculate, using cyclomatic complexity, the minimum number of tests you need in order to cover all the paths in a single subroutine. A lot of people weren't aware of this, but you can do this. For a huge system, well, that's a lot of nodes. It's very hard to do. There's actually a simpler way of doing this. You can just count up all your exit points. So you can, in this case, we have, or your decision points, we have if, else if, else if, else if, else if. And that happens to be 6 decision points. Plus 1 is 7. This assumes that there's only a single return in your code, in your subroutine. So it's not perfect, but it gives you an idea of the minimum number of tests you need to cover all those things. If we had a Boolean conditional, if foo or bar, then that would actually be another decision point in there. Now, cyclomatic complexity, some studies show there's a positive correlation with high cyclomatic complexity and a lot of bugs. Others say that it's not conclusive, and if you have a very high cyclomatic complexity, it may make the bugs harder to fix. That is something we think is true. A large subroutine does not equate to high cyclomatic complexity because it might just run straight through. So don't confuse size with cyclomatic complexity. Also, high cyclomatic complexity might lead to side effects when making changes because you've got all these things coupled together, and it can be very subtle to pick that out. And there's a number of different studies out there. You can read a little bit more about that. In Perl, we have Perl critic utils McCabe. That's an approximation of cyclomatic complexity. It's also called McCabe complexity after the gentleman who discovered it, or who described it first. This one's an approximation because it assumes only one exit node, and it's not integrated into tests. It's a Perl critic tool, so it's not there. There are other tools available. None of them seem to be integrated well into tests, but it's something we should think about, and it's one more thing we should push forward in terms of testing. Now I'm ready for questions. No, Sawyer, I already told you, you can't talk. Yes.
Right.
Give that to someone who is not Sawyer.
Precisely. I am not Sawyer.
You said you were outside. I saw the video.
Prove it. Good point. Specifically about cyclomatic complexity, this is something that Devil Cover should be able to produce easily because it already looks at all those
I have
points.
spoken to Paul about this, and I know it's something that he finds interesting, but he's got a lot on his plate. Perl keeps advancing, and it's advancing very rapidly, so he has to keep updating Develop Cover to follow that.
Okay, fair enough. And another question about your remark, do not trust people who say never and blah, blah, blah.
I'm not saying do not trust people. I'm saying it's a red flag.
Yeah, yeah. What do you think about Uncle Bob Martin, who pretty much only has in his dictionary stuff like never, always, and stuff like that?
I have no idea what you're talking about. Who is Uncle Bob Martin? What is this? Should I know this?
Well, he's pretty much the driving force behind the agile movement, more or less. So, you know.
Okay, so I also have a lot of issues with agile. A lot of the agile movement today is like Scrum. I love Scrum. It's great, but a lot of Scrum is pushing towards a lot of process when we're trying to, in some ways, minimize process. But that's a little bit more of the lean discussion. But that's well beyond what we're trying to talk about here. I tend not to trust people who get too dogmatic. That used to be me, by the way. Roll. Oh, no.
Okay. When we are trying to do tests, you said yourself we're producing anecdotes, and I'm with you 100% there. Might we use something else like an expressive type system? I mean, Microsoft uses TypeScript to try to tame JavaScript. Facebook recently developed Hack to do something with a huge pile of PHP shit. And they're all just spreading a very thin type layer on top of these dynamic languages to eliminate errors. Might there be something for Perl here?
Okay. Okay. What I'm going to say about that is there's a few things to say about that. First of all, be very careful. I like to be very careful when we talk about type systems. As I describe it, computer scientists have reasonable disagreements about type systems. Computer programmers have unreasonable disputes about type systems. When we talk about types, I like to talk about kinds of variables because that gets away from that very, very overloaded term. And yes, if you can narrow down the kinds of variables, static languages tend to do this somewhat well as a general rule. And that's why there's a lot of tests that they don't have to write. They don't have to verify whether or not they passed a string to the reciprocal function because it's going to be a compile time failure.
Don't talk about kinds because in Haskell, kind is the type of types.
Does anyone care about Haskell anymore? It would be very difficult for me to have a word that is not overloaded in some context there. But. One more question, I guess?
You had one slide about BDD. I'm a fan of BDD because it's a way to communicate with the customers. While what you talked about testing is how the programmers among itself communicate. So there was just one slide. Do you think that BDD is a good approach that the IT architects talk to the customers and prepare some Gherkin documents, and then this is used to create tests and to have executable specification? So what do you think about executable specifications by Gherkin or other BDD tools?
What was the last part of the question there?
What do you think of executable specifications like you do with Gherkin tools like Cucumber and so on?
The issue with that, so I'm over time right now, so let me answer this as quickly as I can. So Alistair Coburn, when he was describing his crystal methodology, particularly crystal clear, which is what the lightest weight methodology out there for Agile, he talked about the 3 primary things which are key indicators of success regardless of what methodology you use. And this was a co-located team. What were the 3 indicators? Co-located team, rapid releases, and easy access to a customer. The problem is, like XP said, you had to have an embedded customer originally, and now they kind of backed off on this. Many times you find it's very difficult to have a customer. Product owner serving as a proxy for a customer, that's also sometimes problematic because it doesn't necessarily know that they're going to be able to figure out a way of describing something in a way that's actually responsive for a customer. I like the thought, but because it's so problematic sometimes to either have a customer or to have a customer who is really truly a representative of the customer, I'm somewhat skeptical of the approach, but that's not to say I dislike the approach. I simply don't have enough experience with BDD, particularly vis-a-vis working with a customer, to say that I can make any definitive statement about that. Thank you.